Okay, in this video lesson, we're looking at just trying to gain an understanding of the different parent functions we have. So in this graph, I've created a bunch of different folders. Each folder is on the left here. And in each folder are the different types of functions we want to get familiar with. So I'm just going to go through each one and kind of hopefully you begin to see a correlation between the name of the function, what the equation looks like, and what the graph looks like. So the first one is constant. So when I click on this, the actual line shows up. Right now it says y equals -1. A constant function is simply a horizontal line. Notice the equation, y equals -1. The only thing that's unique about this line is that it passes through only the y-axis at the number -1. Hence the equation y equals -1. So the correlation is a constant function is actually a horizontal line. The equation is simply y equals any constant, because in algebra, constants are single numbers. So if I move this along the slider, as I move it, all you continue to get is a horizontal line going through the particular number in the equation. All right, so that's constant functions, constant, horizontal. It's almost like EKG with the heartbeat. If you've got a constant heartbeat, doo, it makes a horizontal line, constant function. All right, let's look at linear. You spent pretty much all of algebra talking about linear functions in the form y equals mx plus b. Here's where some clarity comes in. A linear function is not just a line. As you saw from constant function, that was also a line. So the distinction is a linear function makes a diagonal line, where a constant is a horizontal line. Some other specific characteristics you'll see is that in a linear function, you'll have a single y and a single x. What I mean by that is you don't have like x to the second, x to the third. It's technically x to the first. In later lessons, we'll look at the transformations associated with each one. But right now, all we want to do is see a correlation between the name of the function, what you'll see in the equation, and the type of line. So linear functions make diagonal lines. Turning that off, we're going to quadratic. If I open up that folder, y equals x squared is the parent function. Let me speak a little bit about this whole term of parent functions. Each of you have very unique parents. If I saw you in a crowd with a bunch of other adults, I could probably pick out your parents because they have similar characteristics, similar features that you have. So this whole notion of parent functions, that there will be a correlation between the shapes of the figure and the particular family it's attached to. Meaning, if you are a quadratic function or a quadratic function, the graph will be some sort of parabola. So if I switch this around and I put negative, it's still a parabola. If I say added 7 to it, it's still a quadratic. Oops, I put equals. Add 7. I know it's a quadratic function because it still makes the shape of a parabola. This is this whole notion of parent functions and certain function families. All right, that's quadratics. So quadratics, the exponent of 2 and a parabola. Here's a mnemonic device. Quadratics and the number 2 and the parabola. Well, you see the exponent of 2, it makes the shape that looks like a U, and the type of function is a Q, quadratic. So Q, 2U are the mnemonic device to kind of sort of keep things in check. All right, let's move on to cubic. Cubic, as it indicates, cubed to the third power. So cubic and y equals x cubed kind of flow. But now the shape, as you can see, is kind of this little squiggly thing. It actually has a name. The name of this shape is called a tangent curve. Later on in the course, we'll be talking about tangent curves a lot. But here's some mnemonic devices. I see that this little squiggly thing kind of passes through the first and the third quadrant. X to the third. Again, in future lessons, we'll look at why it makes this shape. But right now, we're just trying to make the correlation. If it's cubic, it's x to the third, or x cubed, and the shape is this little squiggly thing, a tangent curve. Passes through first and third quadrants. All right, that's cubic. Now let's go to rational. Rational, y equals 1 over x. I'll turn it on, and we see these two little curves here. First thing I want to point out, rational. The way you spell rational, R-A-T-I-O, ratio, a comparison of two quantities. So when you look at the equation or the function, y equals 1 over 2, looks like a fraction. Rational and fractional, if you will, kind of rhyme. So you can get the correlation that a rational function, somewhere in here, you better see some sort of fractional expression, specifically the x being in the denominator. Now, when you look at the graph, to me, if you have an imagination, it kind of looks like a cursive X. So the ramp in the first, ramp in the third, put these two together, kind of looks like an X. So again, rational functions, 1 over X, kind of looks like this little X thing. All right, let's go to linear absolute value. The equation, y equals the absolute value of x. So that kind of lines up there. So when I turn it on, it creates this v. And we can see linear absolute value as a mnemonic device. Linear absolute value's got the v, makes a shape of a v. The equation, y equals absolute value of x. That one's usually the most straightforward one. Now, what you got to be careful is it's not just linear. There's a difference between linear and linear absolute value. All right, two more. Exponential. Exponential, y equals 2 to the x. I'll turn it on. What you see here in the function, first of all, the x is the exponent, hence exponential function. The x is the exponent, exponential. When I look at the graph, to me it kind of resembles a ramp. And the mnemonic device will be this. Exponential, the x is the exponent. Kind of sounds like the X Games. That's what it reminds me of. Because in the X Games, that's where you've got skateboarders riding on these half pikes, these ramps looking things. So you've got kids on the bikes, on a skateboard, riding a ramp for the X Games. Exponential is the ramp. All right, last one, radical. Radical function, there's the little radical symbol, the square root. When I turn it on, there's the picture it makes. Now, to me, this graph kind of resembles the square root symbol. And you have to have an imagination, but if you recognize, okay, the little cursive part, the little curved thing in the square root symbol. So radical, square root, kind of makes this little root symbol. So if we review, constant, sorry, I don't want to do that. Constant was the horizontal line. Linear was the diagonal. I keep doing this. There's the diagonal line. Quadratic, we're most familiar with because of geometry. There's the parabola. I'm going to go ahead and put this one back to my parent. Cubic to the third power makes a little squiggly thing, a tangent curve through first and third. Rational, ratio, fraction, 1 over x. Kind of looks like a little x thing. Linear absolute value makes the v shape. Exponential, the x is the exponent. X games, the little ramp, and radical functions. There's a little square root, and the picture kind of looks like the little square root symbol. So again, this entire lesson was just to kind of get the correlation between the different parent functions, what the equations look like, and how they correlate to the graph.